Okay, welcome to the second of my video lectures in 2012 for the EG168 module, Scientific and Engineering Skills. I've been listening to some of your feedback throughout the week following on from this week's lectures, and I just wanted to clarify a few things that are obviously causing a little bit of confusion at the moment. This week in the lectures we looked primarily at program control, how we could within our program structure get certain parts of our code executed based on certain conditions using if statements. And also we looked at if we wanted to execute a part of a program multiple times. We wanted to loop over that part of the program, maybe using different data sets each time we loop over it, using loops. And we looked at two different types of loops, for loops and while loops. So I'm just going to do a couple of quick examples demonstrating how this works in practice within the MATLAB computing environment. So just to get us started, I'm going to assign the value 10 to a variable I'm creating A, and I'll assign the value B to the variable, the value 5, sorry, to the variable B. So we now have two scalar or single value variables in our workspace. A is equal to 10 and B is equal to 5. So remember, our workspace by default is the top right hand box within MATLAB. Our command history is bottom right. In the center here is the command window, which is our primary point at which we're interacting with the MATLAB environment, and our current folder, and anything in that is listed on the left hand side. There's nothing currently in my current folder. So we've now got two variables, A equal to 10 and B equal to 5. And we can use the structure that we looked at in the lecture this week to conditionally execute different lines of code based on certain conditions. So let's say our first condition is if A is less than B, and remember I gave you a list of these different logical operators that we can use within the MATLAB environment. And this expression here has one of two conditions. Either it's true or it's false. So either A is less than B or A is not less than B. So we'll say if A is less than B, and then what's listed underneath that expression is what would get executed if that's true. So if A is less than B, let's say we'll just write to the screen. So we'll tell the user using this little program that A is less than B. And we can create, let's say we create a third variable C. And we'll say that C is equal to B minus A. And that's all we want to do. If A is less than B, which in this case of course it isn't, but if it were to be the case, then we would simply write to the screen A is less than B, and we'd compute this third variable C. And if you remember looking at the lecture notes, the next part of this structure would be to say if we had another condition within this little part of code, else if let's say if A is greater than B. So this is an alternative. Okay, so A is less than B or A is greater than B. So we can write here A is greater than B. So that would simply write to the screen A is greater than B. And this time, if A is greater than B, let's compute C differently. Let's say that this time C is computed as A minus B. In this case, A is greater than B. So we're going to compute this variable C. It doesn't actually matter what these things mean in a slightly different way. Now, of course, it's not strictly true that either A is less than B or A is greater than B, because of course A could be equal to B. So what we could say is else, there is some other condition that could be true, else we'll say else A is neither greater than or less than B. It must be equal, or let's put A and B must be equal. End. And now within the command window environment, as soon as I press return, at the end of this little code structure here, so we've got if, an else if, an else, and then this whole structure is ended using this end here. This will run, so MATLAB will execute this little bit of code. So just as a reminder, what we've done here is we've created an expression here and used the if syntax to say conditionally execute these two lines here. First of all, it's just writing a bit of text to the screen. The second thing is do a very simple computation. If this here, A is less than B. Else, if A is greater than B, we're going to execute these two lines here. And if neither of those two things are true, then we're going to write this to the screen. So if we hit that, well, we write A is greater than B, which it was, and C is equal to 5. What we could do now is, let's say A is equal to, let's turn it round, A is equal to, what did we have before? We had A is equal to 10 and B is equal to 5. So let's now say A is equal to 2, B is equal to 3. And I'm just going to copy that little bit of code we wrote and paste it in here and run it again. Okay, of course this time now we have our answer A is less than B, and it's computed C as being equal to 1. We can check that that final condition also works. Let's set them equal to the same thing. A is equal to 10, B is equal to 10, and run that again, and it does exactly what we said, what we think it should do, which is write to the screen A is neither greater than or less than B, A and B must be equal, which of course is the case. Okay, so that is how the if structure works. Now, one of the ways of executing a piece of code multiple times is using a for loop. So we would loop a section of code. So we can do this. Let's just initialize a variable, or just give it an initial value. So we're assigning the value 0 to a variable I'm calling y. And I'm going to write the standard syntax for a for loop. And again, this is all in the lecture notes. Now, if we want to loop over a section of code 10 times, this would be a starting point. We don't need to use the variable I. We could give this variable any name we wanted to. I've just called it I. And what this will do is, between this statement here and when I write end, it will loop over and execute the code that's inside that statement the number of times listed in this format here. This will all make more sense when you start playing with it yourself. So the first thing I'm going to do is just write the value of I to the screen just by writing I, and then I'm going to do something to the variable y. I'm going to add 2 to it. Okay. Now remember that when you've got the single equal sign in MATLAB, this doesn't mean equals to. This actually means assign what's on the right hand side. So do the computation on the right hand side of me and assign that value to what's on the left hand side of me. So you could think of this expression y equals y plus 2 here as being add 2 to the old value of y to give me a new value for y. And then I'm going to end that. So I'm going to loop over these two lines here. The first thing is just write the value of I to the screen. The second thing is add 2 to the value of y. If I run that, it's done it very quickly. I'm going to scroll back up so you can see what's happened. So immediately after hitting return here, it prints the value of I to the screen. Initially I has the value 1, and y has had 2 added to it. Remember, it was initially 0, so it now has the value 2. The next time those two lines of code are executed, I has increased 2, y is equal to 4, then I is equal to 3, y is equal to 6, and so on. And because that happens 10 times, you see the final time it's run, I is equal to 10. At this point now, y is equal to 20 because we've added 2 to the initial value of y, which was 0, 10 times. And finally, we looked at an alternative method of executing a section of code multiple times using a while loop structure. And I'm going to demo how this works by initializing a variable I'm going to call count with the value 10. So I'm assigning the value 10 to the scalar variable count. and then I can say while count is greater than 1. So while this statement is true, keep executing what's between this statement here, the while count is greater than 1, and end, which we'll write at the end of this section. Just keep looping that an infinite number of times until this is no longer true again. Just keep executing the code inside of me over and over again. So we need to be careful what we write inside here. As I mentioned in the lecture, if you don't get this right, you could end up having a bit of code that you get stuck inside of. If this is always true, you'll never get outside of this next little section of code. So what I'm going to do is every time we come through here, I'm going to subtract 1 from the value of count. So remember, this new value of count is the old value of count minus 1. And then I'm going to end that structure there. So every time I come through this single line of code here, and I could have multiple lines of code in here if I wanted to, but every time I come through here, I'll subtract 1 from the value of count, so the value of count will go down. And we can see if I scroll back up to where I initially ran that, so first time we come through, count is equal to 9, then count is equal to 8, and so on. So that little piece of code runs 9 times, because by the 9th time, count is equal to 1. This statement here is no longer true, because count is not greater than 1, so it stops and jumps out of that while loop. So where will you see some of these features in the program that you're going to be working with over the next few weeks? Well, the main program, we also looked at how you can break a larger program down into a set of subroutines or functions, we usually call them in MATLAB. The main program that you're going to be working with is called test mission profiles. This is the code here. This is the main program itself, and you can see it's actually only 17 lines. There are quite a lot of gaps in here with lots of comment lines. It actually boils down to just a handful of lines of code, because the bulk of the number crunching and the maths that's going on behind the scenes is behind the scenes. It's hidden away in these functions. So there are 3 functions. The first one is called calculate mission profiles. The second is called imperial mission profiles. And then the final thing is the function that does all the plotting. It's called plot mission profiles. And we looked at how we call these functions, how we pass data into these functions, and then how data is returned from these functions to the main program. So if I now look at the calculate mission profiles function, which has to be in my current folder for all of this to work, calculate mission profiles, you can see this is a function that's at the top here of the M file that it's saved in. And straight away we can see an if structure that's been set up here. So this statement here says if some variable called narg_in, this actually stands for number of arguments in, is less than 1, then set rocket start time to this. If narg_in is less than 2, set shoot time equal to this, and so on. And each of these if statements has an associated end, and you can see the way the code has been indented. This has been done so that you can clearly identify which end is associated with which if statement. If I scroll down through the code, also here we can see a for structure. So again, here's the beginning of a for loop, and this for loop runs from I being equal to 1 all the way up to I being equal to whatever n is minus 1. So everything that's inside this section here until for meets its partner end further down the code, everything in here will be looped over this number of times, n minus 1 times. And within that for loop, we've got an if structure here. So you can embed some of these code structures inside each other. So we can have an if condition here inside the for loop. So when you start working on the third part of your MATLAB assignment over the next few weeks, make sure you go through the code first of all, identifying where these structures exist to give you an idea of what the code is trying to do. Just to finish off, what I will do is let's open up test mission profiles again, and I will run that to give you an idea of what this does. So initially, some variables are initialized at the start of the program. So the rocket start time is initialized at 0. The first and second shoot opening times are set at 100 seconds. And if we run this, this should predict the performance of the Bloodhound vehicle. And it, by default, produces 3 figures for you. Let's go back to figure 1. So figure 1 is a velocity against time graph. So you can see the initial steep acceleration of the vehicle up to almost but not quite 1,000 miles per hour under the conditions set in this program. Figure 2 then is a distance against time graph. So you can see how the car's progress down the track evolves with time, and then finally we've got acceleration measured in the slightly bizarre units of feet per second squared against time. So you can see where Andy Green, our driver, will be accelerating at his maximum value and then decelerating at this point. Again, these are based on the default input position variables that I've given you for this program. One of the jobs that you'll have to do in your assignment over the next few weeks is try to optimize some of the input parameters for this program to maximize Bloodhound speed. I hope that was useful. Again, send me your feedback by coming to see me in the lab sessions or via Twitter or via email, and as the term goes on I will create more of these online video lectures.